Happy Tuesday, everyone. Hope that you're having a wonderful day. I know this is a weird week. It's Fair Week. We only have 3 days this week. Of course, Thursday even is kind of a shortened day. Today, I know there's some stuff going on. Colleges are set up in the cafeteria. So, anyways, we're going to do something that's pretty easy today considering what we were able to accomplish last week. So, second and third period, last week you guys ended on a quiz. And this is just kind of picking up right where we left off. For you guys who are in my fourth and fifth period class, you did a worksheet called Representing Quadratics. You had 3 problems to do over the weekend. Actually, most of you probably were done with it before. This is also picking up right where we would have left off. And it's actually kind of doing something that we already did. You see, today we're talking about solving quadratics by factoring. So last week we spent a lot of time on factoring. We factored using greatest common factor. We factored trinomials into 2 binomials. We even factored binomials into 2 binomials if they were difference of squares. So we've done the different types of factoring. So what we have different in this particular section is they're going to have an equation. And when there's an equation, we've got to make sure, of course, see if you look down here, there's equal signs on these problems. And when that's the case, we have to make sure, and first of all, we got to move all the terms to one side where you have an equation that's set equal to 0. Then step 2 is we're going to factor, and we're going to use one of the different methods that we talked about last week. We're always going to start with GCF, right? That's got to be first. If we have a greatest common factor, then we do that. We factor it out, and then we go from there. After, of course, you take your problem and you factor it as far as you can, step 3 is the new part. We're going to actually take those factors, set them equal to 0, and we'll solve for what those x values actually are. And then we'll write those as a solution set. Of course, that one's not as important. And I'm going to show you one other thing real quickly about this. So we're going to go down the left side and do all the odd problems, and that's going to leave you with the evens for homework. So like the first step said, we've got to make sure that this is set equal to 0. And it absolutely is. So we're done with that part. We move to step 2, which is to factor. And if you look at this one, I hope that you notice a couple of things. This is kind of the process I want you to go through. One, it's 2 terms, right? 2 terms. So second thing is, does it have a greatest common factor? And I hope that you notice that there is an x in at least both. See, the first term has x squared. The second term has an x. We can factor out an x. So if I factor out an x, okay, if I factor out a greatest common factor, x squared divided by x is x. And positive 9x divided by x is leaving me with just positive 9 in that term. So we have factored this as far as it can be factored. Think about it. It's still a binomial. It's definitely not difference of squares. And that's the only type of binomial that we've learned how to factor. So I have 2 factors here that are both very important. And the reason I say they're very important is they both have a variable. See, that one is x, and this one is x plus 9. So what does step 3 say? Step 3 says to take your factors and set them equal to 0 and solve. So if I take that first factor of x and set it equal to 0, it's already solved. X equals 0. And then, of course, if I take the other one, x plus 9, and set it equal to 0, and I solve that, how do I solve? By subtracting 9. So 0 minus 9 equals negative 9. So my solution for this is x equals 0 and negative 9. Now, that is not an ordered pair. That is a solution set, meaning that's 2 solutions. That's 2 places. And I want to show you guys something real quickly. Let's go to our calculator. And you might have a calculator close by. I hope that you grabbed one. I ask you to when you come into class. That should just be automatic. But I want to show you guys what we're actually doing when we're solving a quadratic by factoring. You see, what I'm actually doing is I am finding, look, I'm going to take this very problem, x squared plus 9x, and I'm going to graph it. And I want you to notice something. Look at where it's crossing the x-axis. It is crossing the x-axis right here at 0, and it's also crossing the x-axis, if you count all the way over, at -9. So the two places where it crosses the x-axis is -9 and 0. Now go back over here with me real quickly, and then hopefully this will all make sense to you. And I'm not going to do this with every problem because it's absolutely true. What were my two solutions? They were 0 and they were -9. You see, all the stuff that we talked about last week when we were factoring quadratics was leading us to this point. By factoring a quadratic, we are actually finding the places where a quadratic will cross the x-axis. That is what these factors will give me. See, one of them gave me the x-intercept of 0. One of them gave me the x-intercept of -9. So when we factor a quadratic, what we are doing is we are actually finding the factors that once I set them equal to 0 and solve, it gives me the zeros, meaning it gives me the places where it crosses the x-axis. We call them the x-intercepts. So like we talked about last week, when we wrote our equations in the three different forms, when it was in what we called vertex form, we could see the vertex, right? When it was in standard form, we could see the y-intercept. The last one is factored form. When it's in factored form, we can see the x-intercepts. And these are all the three important points that a quadratic will cross in a coordinate plane. The vertex, where it originates from, the y-intercept, where it crosses the y-axis, and the x-intercepts, where it crosses the x-intercepts. So this is putting it all together. Kind of like what we did in 4th and 5th period on the last day of school last week. I think it was Thursday. That is what we're doing today. We're taking these factors, setting them equal to 0, and solving. So look at this one. We have x squared minus 4 equals 0. So if I look at that problem, it is set equal to 0, so I don't have to do anything there. So what I need to do is I need to focus on my factoring. Well, is there a greatest common factor? Can I pull something out of x squared and 4? Well, definitely not. So what I should notice here is it's a binomial. It's two terms. And there's only one type of binomial besides greatest common factors that we learned how to factor. And that is difference of two perfect squares. Well, is x squared a perfect square? Absolutely. X times x. Is 4 a perfect square? Sure it is. 2 times 2. So this is the one time where I told you a binomial factors into two binomials. And those two binomials are x and x, right? X times x gives me x squared. 2 and 2, because 2 times 2 gives me 4. And what was the rule on this difference of squares? One had to be positive and one had to be negative. So there's my factors. So what are we supposed to do with them? What's step 3? What's the new thing that we're doing today? We're taking those factors, x plus 2, setting it equal to 0, and x minus 2, and we're setting it equal to 0, and we're finding the places where this graph crosses the x-axis. And look at it. It's at -2 because, see, I subtract it, and it's at +2 because I add it. So my two solutions are -2 and +2. Remember, those are not ordered pairs. They're a solution set. Those are both the x-intercepts, okay? It's not a point at -2, +2. It's saying your x values are at -2 and +2, okay? So solving by factoring. Look at number 5. And again, we've done all this. It's just that now it's set equal to 0. So we're trying to solve by factoring. So the first thing you're supposed to check is there a greatest common factor? Can I pull something out of x squared, 10x, and 21? Definitely not. Nothing comes out of x squared as far as a number besides 1, and that doesn't help me. And there's no variable in 21. So I can't pull out a greatest common factor. So the next thing I hope you notice is it's a trinomial. 3 terms. Well, we talked about factoring trinomials into two binomials. Two binomials. Hopefully you recall that. So we all start right here. what will multiply to get x squared? Well, that's x times x. Remember that? Then we look at this sign. What multiplies to get a positive? Remember we said, well, that means they're either both negative or they're both positive. So we look right here at this middle sign, and sure enough, they both have to be minus. So the last thing is, since those signs are the same, we're looking for the two numbers that will multiply to get 21, and those same two numbers will combine, because the signs are the same, they'll combine to get 10. So think about that for a second. To multiply to get 21, but to combine to get 10, the numbers have to be 7 times 3. 7 times 3 gives me 21. 7 and 3 combine to get 10. There it is. So those are my factors. So step 2 is done. We factored it. So what do? Step 3, we take our factors, we set them equal to 0, and we solve. That's the new thing today. See, we're not doing anything that's hard and new. We just take these factors once we've factored them, and we set them equal to 0, and we solve. So this one we're going to add 7, so x equals 7. This one we're going to add 3, so x equals 3. So my solution set includes the x values positive 3 and positive 7. If you were to graph it, I promise you, that is where you would see it cross the x-axis. Guarantee you. That's where it crosses the x-axis. Try it. I promise you it's true. All right, let's keep on cruising along here. Number 7, last one on this front side, and then we'll flip it over to the back. If you look at this one, it's already set equal to 0. We don't have to do any work as far as that goes. Now on the next page, we are going to have to move some things, but here, nothing. Now, if you look at this one, I know a lot of times you see all these 3's and you think, okay, I can pull a 3 out. But 3 won't come out of 13. So sure enough, there is no greatest common factor. So since this a value is not 1, this is one where we're going to utilize that method I taught you called the over-under. So I want us to try that here. So here's what we're going to do. We're going to ignore that 3, and we're just going to write x squared minus 13x, and then we're going to multiply. What is 3 times 30? Well, that is a 90. So we're going to have minus 90 here. And that's what we're factoring, okay? We're doing the over-under, so we've got to factor this. So we're going to factor it. And again, what makes it easy is, because this is now x squared, we're just going to put x and x. And we're looking for the two numbers that will multiply to get negative 90, but combine or have a difference of negative 13. So first of all, to multiply to get a negative, remember what the rule is? One of them has to be plus and one of them has to be a minus. And it doesn't matter where I put them because they're both x's right now. So we're looking for the two numbers that multiply to get 90, but have a difference of 13. So if you play around with some numbers, and again, we talked about this the other day, to do that, and let me just show you, okay, in case you forgot, we're just going to take 90 and start dividing it, okay? So I'm going to take 90 and divide it by 2. Does 2 and 45 have a difference of 13? Well, for sure not. So then we take 90 and we divide it by 3. Nope, 30 and 3 have a difference of 27. So then we're going to take 90, we're going to divide it by 4. 22.5, that's not it. We take 90 and we divide it by 5. 18 and 5, sure enough, what's the difference between those two? 13. There it is. It has to be 18 and 5. Now, it does matter which one goes with which, and here's why. Negative has to win the middle sign. So negative has to go with the bigger factor, and the bigger factor here was the 18. Remember, the 5 was smaller. So that negative 18 with that positive 5 is what will allow that to be a negative 30. So here's the deal. We have now factored this as far as the over goes, but we haven't done the under. Please don't forget, you've also got to come back now and bring that under, that 3, that we had worked out earlier. Now, on that first factor, those, of course, do not break down any. So we're going to rewrite that as 3x plus 5. But that second one definitely does. 18 divided by 3 is 6, so that turns into just x minus 6. So there's my factors now completed because I did the over and then I did the under. So we take these factors, 3x plus 5, set it equal to 0, and we take the x minus 6 and we set it equal to 0, and now we solve. So first one, subtract 5, so 3x equals negative 5, and then divide by 3, x equals negative 5/3. Now again, if you don't understand that number, that is negative 1.6666 repeating. If you were to graph it, it's going to cross through the x-axis somewhere between negative 1 and negative 2. The other place it will cross the x-axis, if we add that 6, will be at positive 6. So my two solutions for x include negative 5/3, okay, negative 1.6 repeating, and positive 6. That's the two places where this particular quadratic will cross the x-axis. So there's all the different types of factoring that we've done. So let's keep on cruising. Number 9. Now obviously you can see the difference here between the front side and the back side already. These are not set equal to 0 yet, so we have to do it. So how would we move that 5x over where it would leave the right side completely blank? We'd have to subtract it. So that's going to leave us with 2x squared minus 5x, and now we have cleared out where it's set equal to 0. Now we can step back and say, okay, then let's factor this problem. So I see it. It's a binomial, two terms. Is there a greatest common factor? Well, I can't pull a number out of 2 and 5 because 5 is odd and 2 won't go into it. But they both at least have an x. So I'm going to pull out an x. So if I pull an x out of that first term, 2x squared divided by x is 2x, because one of those are going to cancel. But then negative 5x divided by x, the x's cancel completely, and it leaves me with minus 5. So there's my two factors. What I pulled out was a variable. That's a factor. Remember, that's a factor. And it's an important one because it's a variable. And then the other factor was what was left inside 2x minus 5. So let's take those two and set them equal to 0, and we'll be completing step 3. So x equals 0, and 2x minus 5 equals 0. Of course, with that x equals 0, it's done. That's one of my solutions, 0. The other one, I'm going to add 5, and I'm going to divide by 2. And 5 divided by 2, you can either put 5 halves, or because it's a nice decimal, I'm just going to put 2.5. So my two values of x for number 9 include 0 and 2.5. That's the two places where this thing would cross the x-axis, I promise. You can go and graph it. That's exactly where it's going to cross the x-axis, at 0 and at 2.5. And there it is. That's how you do it. You load up one side, you factored it, in this case, using greatest common factor. Then you take those factors, you set them equal to 0, and you solve. Okay, let's look at number 11. Number 11 looks like it has a little bit more going on, but we just need to get everything on one side. Okay, remember, do not factor it, or even try to factor it until you've gotten everything on one side together. Well, I'm going to look at my biggest variable. My biggest variable with these problems are clearly x squared. And the biggest of those two is the 2x squared. So I'm going to move everything on the right side to the left. So I'm going to subtract x squared from 2x squared. And I'm going to add 1 to negative 50. When I do that, that will allow everything over here on the right side to cancel. So it'll be set equal to 0, which is exactly what we want to accomplish. So here it is. 2x squared minus 1x squared is 1x squared. 2 minus 1 is 1. The variable stays the same. Negative 50 plus 1 is negative 49. So what we have is a binomial where I cannot pull out a greatest common factor. What is the only binomial, without it being a GCF, that we've talked about factoring? Difference. Is this difference? Yes. Of perfect squares. Are these perfect squares? X squared is, 49 is. So this is the one time I said a binomial will factor into two binomials. What times what gives me x squared? X times x. What times what gives me 49? 7 and 7. What's the rule? 1's plus, 1's minus, and there are my factors. Now, what do? We take those factors, step 3, and we set them equal to 0. So x plus 7 equals 0, and x minus 7 equals 0. With that first one, we're going to subtract 7, so that's negative 7. And that second one, we're going to add 7, so that's positive 7. So my two solutions for this problem include negative 7 and positive 7. Done. Just like that. All right, that's number 11. Solving by factoring. We're not doing anything hard that's new today. It's all stuff that we did last week, except for we're taking those factors at the end, we're setting them equal to 0, and we're solving. Number 13. Again, I can't solve by factoring until I get everything on one side. So that means I need to take that 80 and I need to subtract it over. So x squared plus 2x minus 80 will give me 0 on one side. That's what we wanted to accomplish. Now, can I pull out any greatest common factor? A lot of people might think, well, you can pull a 2 out because 2 comes out of 2 and 80. But does this x squared have a 2? Absolutely not. You cannot pull out something that every term does not have. So this is a trinomial, no GCF. So we're going to try to factor it into two binomials. Now, how come I know that I can jump right into that? How do I know I don't have to do the over-under thing? Because my x squared coefficient is 1. It's not 2. It's not 3. It's not some other number. It's 1. So these are easy factors. So x times x. What multiplies to get a negative? A positive and a negative. So we're looking for the two numbers that multiply to get 80. But since those signs are different, they have a difference of 2. So let's look. Let's clear out and let's try some of these. 80 divided by 2. And again, these don't take long. That's a difference of 38. That's not it. 80 divided by 3 doesn't work. 80 divided by 4 gives me a difference of 16, getting closer. 80 divided by 5 gives me a difference of 11. That's not it. 80 divided by 6 doesn't work. 80 divided by 7 doesn't work. 80 divided by, most of y'all probably came up with this already, but 80 divided by 8 is 10. What's the difference between 8 and 10? 2. Now, remember, let's go back. We know it has to be 8 and 10. They are the only ones that have a difference of 2. So the last thing that I want you to remember is positive wins. So positive has to go with my bigger factor, and in this case, that's the 10. And of course, the 8 is the smaller. So there it is. There's my two factors. Let's take them. Step 3, set them equal to 0 and solve. So we're going to subtract 10, negative 10. We're going to add 8, so x equals 8. So my two solutions for this quadratic are at negative 10 and at positive 8. Boom. Just like that. Done. Okay? Very, very simple. I hope that you guys are following along and that y'all understand, because we're not doing anything new. We're just adding a little bit on to what we did last week. All right, so again, look. Here's x squared where it's bigger because 2 is bigger than 1. So I'm moving all of this stuff over here. So here we go. Ready? We're going to subtract x squared from 2x squared. We're going to add x to negative 9x. That will allow these to cancel, and that will be set equal to 0 now, which is what we're wanting to accomplish. So let's see what we're left with here. 2x squared minus 1x squared is x squared. That's good. That's going to make this an easy factor. What's negative 9x plus 1x? That's negative 8x, and then minus 65. So that's a trinomial. Look, 1, 2, 3 terms. Nothing goes into each of these terms. Look, this is a 1, and this has no variable. So we're going to factor this into two binomials. Easy, easy. X times x. To multiply to get negative, 1 positive, 1 negative. So we're looking for the two numbers that will multiply to get 65, but have a difference because we have opposite signs here. difference of 8. So let's go see. 65 divided by 2 won't work. 65 divided by 3. And I'm doing all these because I want you to see how easy it is to find them. That doesn't work. 65 divided by 5 I know will work. It's a difference of 8. There it is, 5 and 13. It's got to be 5 and 13. So I look right here, negative wins. So if negative wins, that means it has to go with my bigger factor, and that was the 13. The 5 was smaller. So there it is. There's my two factors. What do I do with them? Set them equal to 0 and solve. So that first one, I'm going to subtract 5, so x equals negative 5. And the second one, I'm going to add 13, so x equals 13. So my two solutions for x include negative 5 and positive 13. We solved by factoring. Okay, look at number 17. Again, where's my biggest variable at? Right here, x squared. Let's bring everything towards it. So I'm going to subtract x, and I'm going to subtract 21. But I don't have anything to subtract these things from. So it literally leaves me with 2x squared minus x minus 21 equals 0. That's what it leaves me with. We got it set equal to 0 now. So now we're going to factor this one. Now look, is this an easy factor? No, that's not a 1. That's a 2. So we have to use the over under. So here we go. Ready? Here's how we do it. We're going to ignore the 2, and we're just going to write x squared minus x. What is 2 times 21? Well, that's negative 42. So we're looking for the two numbers that will multiply to get negative, that's plus and minus, 42, but have a difference of only 1. So let's go try. 42 divided by 2, does that have a difference of 1? No, that's 19. 42 divided by 3, does that have a difference of 1? No, that's 11. 42 divided by 4, no. 42 divided by 5, doesn't work. 42 divided by 6, there it is. There's a difference of 1 right there, 6 and 7. So my factors have to be 6 and 7. Now look, what sign wins right here? Negative. So negative has to go with my bigger one. That's the 7. Whoops. So the 7 goes here, the 6 goes there, and those are my factors. So we set them equal to 0, and we solve. So for this first one, I'm going to subtract 6, and for that second one, I'm going to add 7. So my two solutions for x include negative 6 and positive 7. And there you have it. Okay? So that is 1, 2, 3, 4, 5, 6, 7, 8, 9 problems we've done. That leaves you with 2, 4, 6, 8, 10, 12, 14, 16, and 18. 9 problems for homework. So I want you guys to do this. Listen, you can do this. I know I'm not here, and a lot of times we use that as a cop-out, but this is factoring just like we did last week. The only difference is once I've factored it, I take those factors, I set them equal to 0, and I solve. Okay, so tomorrow we're going to go over this. For 4th and 5th period, I will not only go over this, but I'll also go over the representing quadratic equations from last week. So make sure you have that completed tomorrow as well. So there you have it. Listen, if you have any questions, you need to mark those ones that you really struggled with understanding. And tomorrow when I get back, I'll be able to get right into those and help you out, make sure you understand it. Hey, have a great Tuesday. We'll see you tomorrow.